A reference angle is the shortest positive angle, just the smallest positive angle that gets you between your terminal side and the x-axis. So for example, we have here, if our angle is in quadrant 1, the shortest way to the x-axis is just the angle, so it's the same. But here, if we're in quadrant 2, the reference angle is that little piece, that angle that gets us to the x-axis. So we're always looking at what's the shortest way to get to that x-axis. Okay, if we're in quadrant 3, it's this little section in here. That is our reference angle. And in quadrant 4, there's our reference angle. So let me just do a couple examples. Let's say that our angle is 218. For me, it's always helpful to draw a picture. So 218 degrees gets us here. Just remember, here's 180. So 218 would be there, and then I'm in quadrant 3. So to find my reference angle, which we can do with that dash, or some books do it with a bar over the top. Both of those are nice ways of showing reference angle. So that's just the difference between our angle and 180 degrees. So we would just take 218 minus 180. And that is our reference angle, which is 38 degrees. And that's this little section right in here. Okay, let's try one more example. Let's say that we're at 5 pi over 6. All right, so let's draw a picture, remembering pi, if we're counting in 6 pi over 6 is the same thing as pi. So at 5 pi over 6, we're in quadrant 2. We haven't quite gotten all the way over. So we're right here. And we are looking for the reference angle, just this little section right in here. And so we're in quadrant 2. So the way that we find our reference angle is we take 180, which in radians is pi, and we subtract our angle, which is 5 pi over 6. And so that would give us, well, pi is the same thing as 6 pi over 6, so that would give us our reference angle of pi over 6. Now, it gets a little bit more complicated when we're dealing with negative angles. So let me do a bunch of examples for you. All right, I'm going to start off with an example where theta is negative 45 degrees. So I'm coming backwards 45 degrees, okay? And so the reference angle is just this little section in here, and it's just the opposite of my angle. It's positive 45 degrees. So it's the shortest positive angle that gets us to the x-axis. Okay, so the theta here is the opposite of negative, and it's a positive 45 degrees. So the general rule in quadrant 4 is that our reference angle with negative angles is just the opposite of the given angle. Okay, let's look at another example. How about negative 5 pi over 3. So negative 5 pi over 3, let's see, this would be pi, which is negative 3 pi over 3. Here's 4, here's 5. So we're going around to negative 5 pi over 3. And what we're trying to find is just this little section right in here. I don't know if it's helpful to do it in green because we want it to be positive, okay? So you can kind of just look at it and think about like what's the little puzzle piece that would fit in there. The size of that piece is thirds, and to get us all the way around would take an additional third. So our reference angle is going to be pi over 3. Okay, and the way that we get that is the kind of the general rule is we're going to take our angle and add 360. Or if we're in radians, we're going to add pi, or 2 pi, sorry. Okay, so we're going to take our angle, negative 5 pi over 3, and we're going to add 2 pi, and then we can convert that to thirds. So that would be the same thing as adding 6 pi over 6. oh sorry, 6 pi over 3, because we want it to be equivalent to 2 pi. Okay, and so then that would give us the pi over 3, which is that little missing puzzle piece. There it is. That's the little part right there. That's our reference angle. All right, let's look at another example. How about when we end up in quadrant 2? So for example, negative 7 pi over 6. So it'd be coming around in the clockwise direction because it's negative. Here's pi, which is the same thing as 6 pi over 6. And I'm getting a little bit past that. So this is negative 7 pi over 6, and I want my reference angle, which is this little short section that gets me back to that x-axis. Okay, and it's just pi over 6. Okay, but the way that we kind of get that is we're going to take, let's see, we're going to add our angle and 180. When you do that, you'll end up with a negative angle, and so you're just going to take the opposite of it. So that's the general rule. Oops, let me write it up here. Okay, so you're going to take the opposite of what happens when you add your angle and 180. Okay, so here, since we're in radians instead of 180, I'm going to add pi. So I would get my angle, which is negative 7 pi over 6, plus pi, which is the same thing as 6 pi over 6, and that would get me a negative pi over 6, but I have my angle is positive for reference angles. Okay, so that's just this little section, which is pi over 6. Usually if you can draw a picture, you can really figure this out without having to remember all these general rules. Okay, so now let's do our final example. Sorry that this guy kind of went into this other quadrant. Okay, anyway, he's up there. Okay, so in quadrant 3, for example, if we're at negative 135, so we're coming over here, and the reference angle is this section. Okay, it's the smallest positive angle that gets me back to the x-axis. Okay, so it is 45 degrees. But let me show you how you can find that out. Okay, so you're going to take your angle and we're going to add 180 to it. Take our angle and add 180. Okay, so in this case, we would take our angle and add 180, whoops, to get that value. So being able to find the reference angle is going to really help us with applications. If you have an angle that's really big, like something that's larger than 360, or a negative angle that's smaller than negative 360, that should be a negative. Okay, then here's what we're going to do. It's useful, just let's figure out, let's simplify the angle. We'll get a coterminal angle, and then either just use the unit circle, and we can then at that point start figuring out the trig values, or if it's helpful, if you've memorized the first quadrant of the trig values, then you can use your reference angle. So let me just show an example. Let's say that I am given an angle of 1,935. Okay, so first I want to just simplify that. So I'm just going to divide by 360 just to see how many, how many full rotations there are. So in my angle, it looks like I can go around 5 times, 1, 2, 3, 4, 5, and then I'm going to have a little bit, not a full rotation, about 0.375. So I'm going to end up somewhere, I don't know, in there. Okay, so now that I know I'm going to go around 5 full times, I don't really worry about this decimal. We'll get to that in a second. That actually, this piece is my reference angle. Okay, so I'm going to just subtract 5 full rotations. So I'm going to take my angle and subtract 5 times 360, and that will get me the coterminal angle. Okay, so I could go all the way around 1,935 degrees, but that's exactly the same thing as getting to 135 degrees. Okay, so there I am at my angle, and now I want this little reference angle right here. That's the section I want, which is 45 degrees. Okay, so then we can find that reference angle. We're in quadrant 2, so we take our 180 and subtract our angle, and that gives us the reference angle. Okay, if that's helpful, you can just start right here with your 135, and if you're being asked to find all the trig values, then you can just right now go for it, and you don't have to use a reference angle. Reference angles are really just to make life easier, but if it doesn't, and it's just helpful to look at taking the sine of 135, that's fine. Just pull out your unit circle, and here at 135, let's see, we're at 135. That has an x and a y, both at root 2 over 2, but my x is negative. Oops. Negative. My y is positive. Okay, and then I can just come up with the sine. The sine is the y value, the cosine is, so that's a positive root 2 over 2. The cosine is the x value, and then the tangent is y over x, so that would be -1.